does not include your audio. So recording the other screen, I've got two screens. All right. So today should be a pretty laid back day. We'll go through and just do a bit of a discussion to make sure we know where we're at, what stuff should be done, turned in, if we're on pace. If you're a little bit behind on something, we can still get those things turned in. That's perfectly fine. So we'll make sure of that. Oh, and I got one of you kind souls out there, and I traded a few messages this morning with regarding the Pivot Interactive stuff. So we'll have a quick conversation. Hopefully I remember about that. And actually, I'm just going to type that into the lesson plan so I remember for certain. And also, in case anybody else comes back and wants to take a look, I don't know if anybody even checks the lesson plan or if you just go and click on the assignments that you need to do. But it'll make me feel better if I put that over here. So let's see. Weird. It's sometimes wants me to click to admit you guys into the session, and now sometimes not. So it's letting some of you just join, and some of you it's making me click to say, yeah, come on in. What are you going to do? Let's see. I'll just do a new heading. We'll say Pivot Interactives. Floop, floop, bloop. So so I'm going, all these little alerts popping up, frustrating. So I'm just going to kind of say this out loud while I'm typing this in. The Pivot Interactives lab, you go to that separate website, and there are some different labs and experiments that we've done. Some of them we've just flat out used that PhET simulation for. Some of them we've done some other things with. But if you've submitted a Pivot Interactives assignment, if you've submitted it for grading and then I've graded it, if you want to, after seeing your grade, if you want to make an adjustment or edit some stuff, it requires 2 steps. So if you submitted a lab for grading and you want to improve your score, first things first, you have to email me, email or message me, I suppose, through Google Classroom, that you want to, so you need to email or message me that you want to rework or improve your score on a particular assignment. And once you do that, then I have to click on a separate button that says that I, what does it say? It's that I request something from you, that I request reworking, or that I request modifications or adjustments or something like that. So if you want to improve your score on those Pivot Interactives things, you need to send a message to me through Google Classroom that you want to rework or improve your score on the Pivot Interactives assignment. Then I click some buttons and you're set. Note though that this is only for the Pivot Interactives assignments. Interactives. So you don't need to email me about any of the others. You just need to make sure that you then submit the other assignments through Google Classroom, because I get a little ping, sort of a notification when something is submitted through Google Classroom, and that's how I know, hey, go back there and make sure these people earn everything they've earned. So there you go. Any questions on the Pivot Interactive stuff? A couple of head shakes. Leaving a little bit of time for folks to type into if they want to type into. All right, looks like we're set. So, um, let's see. Double checking. Conferences, I haven't mentioned this. I've forgotten to actually mention this the past couple of live sessions that we've had. Last week we had conferences, or every teacher is doing conferences on slightly different nights. They kind of open things up so we could do them at times that uh, might work better for our schedules. So last week I had conferences on Tuesday and Wednesday night from 4 p.m. to 6 p.m. I still have one more night of conferences available. That's tomorrow night from 4 p.m. to 6 p.m. We'll zoom in here, see if this makes anything any better for y'all. So tomorrow night from 4 p.m. to 6 p.m. Um, if your parents or if your family would like to do conferences with me, this is available for them. I sent them the link earlier, but the lesson plan, one of the reasons I do lesson plans in this document separately is that it's shareable and viewable by anyone. So it's sometimes nice for people just to see that. Um, but if your folks want to schedule a conference for tomorrow night, they can use this link and you can just flat out share the lesson plan with them. And there you go. All right. I think that's all the odds and I was going to say, I think that's all the odds and the ends, but actually, it's probably also worth having one more discussion about other stuff before we get to content. Oh, Uh, I just thanks for interrupting me, or thanks for not interrupting me. Thanks for commenting. I appreciate that. I just saw I just saw the comments, and I was intending to, but no. Uh, thanks for the heads up. Let's see. We'll do this. My apologies. Once I set up to record, I normally record after I share my screen, and I did it the flip flop on this time. So thanks to those of you in the comments. It took me 4 minutes before before I actually got there. Oh lordy, lordy. All right. Well, hey, I do appreciate you guys commenting and then on the chat and then also saying something. I really appreciate it. Thank you, folks. That's really helpful. Kind of you. So conferences down here. It is available uh, in this link in the lesson plan. And what was the other thing? Oh, the Pivot Interactives thing. I just typed that in here. I think I said everything out loud, so I think hopefully that makes sense. The other thing before we do physics content is just the reminder on timelines for quarter 3. We do have school this week. And I said through the 26th, but I think actually is the 26th Friday, and I think there's no classes for you guys on Friday, if I remember correctly. So I think I need to change this. I think it's the 25th. I think this is just a Monday through Thursday sort of a week. Teachers have a work day. I think we have meetings and stuff on Friday this week. I think that's true. So we have class through Thursday this week. Then next week is spring break, so no classes. Then we come back and we have class again April 5th through April 9th. Still all quarter 3. I last I heard they were talking about like April 8th and 9th being days that students are not in the building as we try to prepare for quarter 4, which is going to be a little different setup. So um, quarter 4 starts on, I think it's April 12th. And at that point, you and I won't have our this Physics 9 class anymore. You'll be moving on to different things. There are some folks that are still working on getting some things caught up, and we'll work through it. So no stress, just keep plugging away. So there's all that. Any questions on any of the things I've said? I'm taking trying to keep my eyes on the chat a little bit more now. Um, I'll give you a couple of seconds if you have any comments or questions or concerns. I'm going to sip my coffee. All right. Not a huge amount of time there waiting, but some. Okay, so the stuff today is the last day. There's one thing I wanted to make sure we did, and I realized my initial plan for the home circuit like summary piece was to try to fit the fuses and circuit breaker stuff in to one of the previous days, but to me it felt like that. Um, some people surely would have been able to fit that in and figure some stuff out on in that same amount of time. But it also felt to me like if I threw fuses into one of the previous days, that might make it a little bit too long for some of us, and um, it doesn't make any sense to do that to any of us right now. And there's an albino squirrel out in my yard. There you go. All right. So fuses. We'll just go through. We'll discuss this, and this is essentially the stuff that is in the assignment posted today. So any of you that have already done that assignment, you can essentially say goodbye. If you've turned in today's assignment, I'm not offended. If you just say, "Hey, I've got other things to do," and you hang up at this point and you go work on other classes, that's perfectly fine because we're basically going to use this time to go through that assignment dealing with fuses today. So um, there's that. So now I move on to today's assignment: home circuits, fuses. Um, Opening this bugger. Mr. Wizard was apparently it was a TV show. My dad used to talk about this when he was a kid. This was like the show. He loved it. My dad was a farm kid, and oops. Um, but this was a show that he would watch growing up, where Mr. Wizard was some sort of a science guy, and um, they would do different experiments and things on TV, and go through and discuss the science of things. When we watch him, there were a couple of moments where he like grabs a little kid's arm, and I'm kind of like, there's a kind of a creepy vibe for me. But uh, according to my dad, this guy was the man when it comes to um, working with kids and trying to figure stuff out. Um, so, oops. You can just hit play here. I will go through and I'll show what he's doing and just kind of discuss things. I don't think you'll be able to hear the audio from my end, and that's okay. Uh, if you watch this separately, you can hit play and it plays in this little small screen here. If you click on the link down below, it will open it up in a separate YouTube thingy majigger here. Floop. Come on. I tried to, oh, that's not the button I was thinking. We'll make it this one. Well, this is not great. There we go. All right. Um, so, um, all of these different little things. Here, I hope play. Oops, not that button. Play. There we go. Um, you guys can't hear him talking, can you? Can you hear Mr. Wizard talking? No. Okay. Thank you. I appreciate the head shakes. So let's see. Um, I need to turn him down then because he's like yelling in my ear. Um, Come on now. As delightful as Stacy is, I don't need to. Oh, that's much better. Okay, so right there, they're just talking about circuits and fuses. Different people have different backgrounds on these things, and well, I'm gonna go through and adjust playback speed, so we're not doing this for 5 minutes. Um, So he has just a metal wire going across there, turned a switch on, and now current goes through that wire first. And then after it goes through that wire, it splits off and goes to power these lights. And they just hung that little piece of paper there to make things a little bit more visible, which I think is a really clever way to go. So they've got five, pausing it for a second. So they have five or maybe six light bulbs lighting now, and those are old school 100-watt lamps, the ones that have a filament in them, and the ones that the bulbs that get hot. So they have five or six light bulbs going. All of the current that goes to those light bulbs first goes through this wire. Then, after going through that wire, it goes to all of those five or six, or soon to be seven or eight light bulbs. And we can see that this piece of paper that was hung here just to kind of make things a little bit more visible, that's getting hot. And hopefully you can see that there's some smoke there. Um, and that piece of paper now looks like it's burning through, and we definitely see that that wire now is just flat out glowing. That wire, so much current is going, so much current is going through there that it's getting really hot, and so hot that it glows. And that's actually how all old school filaments work. All old school light bulbs work that way. um, is that the light bulbs, where if you touch the old school light bulbs and they get hot, not LED light bulbs, not compact fluorescents, but all the old school light bulbs, they work where current goes through the wire, and so much current goes through the wire that it gets hot and glows. And so light is actually a secondary product of that thing. It's comes with the heat. And so they had 12 bulbs going. Let's see. So they just have 10 bulbs going, and we'll see if they go back to the showing the 11 and the 12. No. So right now they have 12 bulbs going, and that wire didn't work. So it's like, hey, we got up to 12 bulbs. Each one of those bulbs is 100 watts. So they have, or each one of those 100-watt bulbs uses 100 watts or 100 joules of energy per second to light up. So that's 12 times 100. That's 1200, 1200 watts before that thing burns out. Um, on the on this, we can say, hey, all of those things are lamps or bulbs. How many devices before the fuse blew? Well, they hit 12. And now, um, for this, we can see that there are two different ways. I'm going to zoom in here again just to make sure we can see this. Two different primary ways that we could end up using this sort of a circuit where we have 12 light bulbs going. We could either put them all in series, or we could put each of them on their own path. So, so we're going to try to figure out how this stuff goes. And in the comments, somebody asked, is that how toasters work too? Yeah, that's toasters. That's, they switch over and they start using an iron. If you have an electric oven, or electric stovetop, all of those things work, or and many space heaters work in this exact same way, where so much current goes through these wires that they get hot and they start to glow and they emit heat. So I'll tell you what, my stove top is right around the corner. So if you have one of the old school stove tops that looks like that, yeah, um, that looks like that. If you try to look at check the camera view instead of the presentation thing. So if you have one of the stove tops that looks like this, that's the exact same thing, right? This is really just a conductor where where electricity flows through this, in on one side, through the heating elements, and out the other. And the heating elements are just conducting current, and this thing just gets hot enough. There's enough current going through that it gets hot and heats up your pot of water for your ramen or water or whatever you're making. Um, yeah, a lot of those different things work that way. Water heaters have a similar sort of thing. There are gas-powered water heaters and electric water heaters. Electric water heaters work the same way. A lot of things work off of that way. Thanks for the question and comment in the chat there. Appreciate it. So now, when the girl Stacy, I think her name was, turned on 12 different lights. the decision then is like, which way did she do this? Were those bulbs wired like the one on the left on my screen or the one on the right? Well, if you're going to try to turn on each bulb separately, this version does not work to turn on each bulb separately. In this circuit, all 5 of those bulbs are on the same path. They're either all on or they're all off. They're all in series. So it could not be that one. It must be this one. So all of those bulbs are on separately. If we put a switch, we could put a switch right here, or a switch right here, or a switch right here, right? And we could turn on each one of these paths separately and individually. So that's the route. This is the way all of those things must be wired. And that's the way our house is wired, right? If your house is wired in parallel, then you can turn one light on without turning all lights on. And, you know, we obviously can turn one light on at a time, right? You don't have to turn on every light in your entire house, thankfully. Um, moving on. Um, um, and then I just put the link here again, just in case. And now if this is the way the circuit is wired up, where we have like 2 different things here, and maybe we say this is the refrigerator and this is the microwave, just as an example. Here, I'll do this again. So if this is the refrigerator and this is the microwave, the question here is, which of these locations could we put a fuse that protects the entire circuit? So when when these guys were working with this setup, what this fuse does is it protects the main circuit breaker, the main power box, from overheating. This fuse blows instead of the entire circuit to your house going up and maybe starting a fire. Just this one controlled fuse goes. This doesn't protect each individual item. This protects like the wire that goes into the power box. So if we're trying to protect not just this, if we put a fuse at B, that protects just this device, right? If we put a fuse at D, it protects just this device, right? Which is worth protecting, but usually those sorts of circuit breakers or fuses actually just come on the device itself. A lot of electronics will just have their own fuse or a thing like that. Or if you have a power strip, sometimes people get power strips that you'll plug things into. If you have a power strip before your computer, that power strip has a little fuse or a circuit breaker in there too. And we have the question, does the light bulb work? The These light bulbs all do work. Yep, these all work. And you can maybe see off the top, there's a little glow on the top of these things as they turn them on. This bulb, this bulb, this bulb, they would work if they were turned on. They didn't get to 14 or 13. So the fuse blew out before 12 or before they got to 13 or 14. Um, All right. So if we're doing, come on, little thingamajigger. There we go. So if we put a fuse here, that protects B. If we put a fuse here, that protects C. So the question becomes, hey, you're very welcome. The question becomes, where do we put a fuse that protects like the battery from having too much current flowing into or out of? And really, there are 2 options that work. Option A and option E have all of the current flowing through them. So if this is only supposed to get 25 amps total, and these wires are thick enough for 25 amps, if you put a fuse at A or E, that protects the circuit. If you put a fuse at C, that really only checks B. So scrolling down, that'd be A and E. We're getting close to the end. I think we still have a few minutes, but we're getting close to the end. Like I said early on, if you're done with this assignment already, you don't need to hang out with us. You could move on. If you're not done with this assignment, you can hang on and we'll see what we've got. I do have a meeting at 11, so I also am going to have to make sure I'm uh, I'm moving on. Keep pressing the next on the Google form and it's not working. That's weird. Make sure uh, make sure you've answered things. There are sometimes a question is required, like your first name, last name, and those sorts of things. Sometimes those questions are required, and if you skip it, it won't let you move on. This video, uh, and to the person that made that comment, um, uh, if you want to keep trying or try later and send me a message, we can try to work that out. Um, Goodbye. Somebody's saying goodbye. I'm trying not to name names, so when I post this online, the names don't cause an issue. So this guy goes through this old house. I love this show. They go through and they're doing some wiring. The back button doesn't work either. I'll have to go. I'll go through in a second, sir, and I'll check to make sure that things are arranged in a way where that all works. I don't know what that would be. So they go through and they're talking about circuits, and right now he's talking about, it might be difficult to see there. Let's try this. They talk about the thickness of the wires being able to handle different amounts of current. And so actually you can, when you're wiring your house, you can get different gauge or different thicknesses of wire to do these different things. The big drawback of fuses, so a fuse in a house is like this sort of a thing. And the big drawback to those fuses, that's the old school fuses. The big drawback to fuses is that it's literally just a piece of wire. And if too much current goes through it, it just burns out. And it's designed to burn out. And that's how it protects your wiring. But the problem is once a wire burns out, and there they're showing it right there, a little piece of wire. The problem is that once that wire burns out, you can't like piece it back together. So you basically throw that fuse away, and you need another fuse to put in, or that entire circuit doesn't work. So, and that entire circuit in your house doesn't work until you put a new fuse in. And so it still very much functions as a safety feature. It still does its job there. It's just inconvenient because you need to have a pile of fuses on hand to keep replacing them if they burn out. And it's wasteful, but for most folks, the big issue is convenience. Nowadays, we would consider the wasteful thing to be annoying as well. But the fact that they're disposable, not reusable, that's the big drawback to fuses. In terms of safety, they work just fine. They are reliable. They're not crazy expensive, $5, $6, $7. And when we say a fuse burns out, we literally mean that that little metal piece got so hot, it melted and burnt away. Oh, you reloaded the form and it works now. That's awesome. That's great news. Thanks for sharing. And the big benefit of circuit breakers is that they're reusable. I mean, if for a circuit breaker, if the circuit blows, you just flip the switch and you're good. And then I think the next page is really just the reminder that, how long did it take you? I think this took us about 20 minutes. And then when you click submit, we'll go through and just double check this. I was talking with some folks that were having some issues. Once I click submit on these forms, what I would suggest is clicking on these things. I right click on it, open it in a new tab. And then if I want to edit my response, I right click on that and I open it in a new tab. And now I can check my score, 7 out of 8. What? Oh, well, we have the right one there. I need to change the form because that's the right answer. But so now we know what we've got there. And if I use this, then I can use this other one to go through and edit my answers. And at that, I need to hang up on you folks and go to my next meeting. If you have any questions or concerns, you can email me and we'll work through what we need to work through. Have a good day, folks.